In part 3, I'd like to look at the issue of adverse selection. So in this problem, as it's set up, we have two farmers: a high cost farmer for conservation effort, farmer 2, and a low cost farmer for conservation effort, farmer 1. And the regulator would really like to offer these farmers separate contracts, but as we will see, there's an incentive for the type 1 farmer to actually choose the contract that would ideally be offered to the type 2 farmer. So the problem with that is that you're paying type 1 farmers, the low cost farmers, more than you need to for their conservation effort, and the conservation scheme will lose efficiency. So the difference in profit loss from conservation effort can be seen in this diagram here, and we see that we've got type 1 has got a low profit loss due to conservation effort, and type 2 has got a relatively high profit loss due to conservation effort. We've already derived the first best solution, but we can actually derive the first best solution or the perfect information solution by just adding the two objective functions together for contracting with the two farmers. So that's what we have here. So we see that farmer 1, the low cost type, has got a relatively high effort and gets a high transfer payment, whereas farmer 2, the high cost type, has a low transfer and a low effort, and this gives the overall value of contracting with the two farmers. Actually, implicit in this is an assumption that both the farmers appear in the population of farmers with equal frequency. Now, the next step is to check if farmer 1 would like to pretend to be farmer 2. Okay, so is there any incentive if the regulator is trying to offer two separate contracts? Is there any incentive for farmer 1 to choose the contract that's intended for farmer 2? So we check this by taking the profit function for farmer 1 and substituting in the effort for farmer 2 and the transfer payment for farmer 2, and also we've got there the profit without any conservation effort. So if we do that, then what we find is that farmer 1 earns a rent which is equal to 5.165. So the contract they're being offered pays them no extra money over and above their cost of effort. That's the first best solution. But if we set it up so we've got the two farmers being offered separate contracts, then there's an incentive for farmer 1 to choose the contract intended for farmer 2, and we can just check that. I just need to evaluate all of those. We can just check that. So if we revert that back to farmer 1 getting the contract that's intended for them, then that number is 0. That looks like a strange number. It's 10 to the minus 15. So that's 0. And similarly, if farmer 2 gets the contract that's intended for farmer 2, then their profit is 0. They're not getting any extra over and above what they would get to what they're getting to cover their cost of effort. But if instead we offer the 2 separate contracts, but we ask whether farmer 1 would choose the contract that's intended for farmer 2, then suddenly farmer 1 gets a rent. But is there any incentive for farmer 2 to do this and to select the contract intended for farmer 1? No, because that actually makes them worse off, in fact, by about minus $20. So this is what's called adverse selection. So the regulator can't observe the cost of the farmers complying with the contract. The regulator tries to offer 2 contracts that is differentiated between the two producers, but because of asymmetric information, then that's not possible. There's what's called an information rent that's earned by farmer 1 if the regulator tries to do that. So how can we how can we address this problem and overcome this loss of social welfare where farmer 1 pretends to be high cost? Well, we use something called mechanism design, and this is, I think, one of the great ideas of economics, and it also shows how flexible mathematical programming can be in terms of solving a very wide range of problems. So we have here the problem where we're trying to maximize the society's welfare from contracting with the 2 farmers, and implicitly we're assuming that they're in equal proportions in the population. We have 2 individual rationality constraints, one for farmer 1 and one for farmer 2. And then we have this what's called incentive compatibility constraint. And what this is saying is that profit for farmer 1, choosing the contract for farmer 1, must be greater than or equal to the profit of farmer 1 choosing the contract that's intended for farmer 2. So that's all you have to do to sort this problem out. And what's happened here is that the low-cost farmer has the first best level of effort, but they're getting a larger transfer payment, so they get some rent. They're better off. To reduce the cost of this rent, then the effort for farmer 2 is reduced, and the transfer payment for farmer 2 is also reduced, and poor old farmer 2 gets no rent, so they're no better off. So the way to compare that is to look at the 2 solutions. So if you compare the way that they work is that the profit from farmer 1 choosing the contract intended for farmer 2 is 9. In this case, it's 9.725, But then if you look at the profit for farmer one choosing the contract intended for itself, then it actually gets exactly the same. It gets exactly the same profit. So it's indifferent. The farmer is indifferent between choosing the contract intended for the other farmer and the contract that is intended for them. In fact, you could add a bit more to the transfer payment just to make sure that they clearly want to select the right contract. And we can summarize the results here. So first best or perfect information, effort, and the transfer for type 1, type 2, mechanism design for type 1, and so I just need to reevaluate that lot. Sorry, I need to reevaluate that and reevaluate that lot. Okay, so just to run through again. So first best type 1, first best type 2, mechanism design for type 1, mechanism design for type 2, and the way you get over the adverse selection is you just give type 2 a weaker contract which requires less effort, and you give type 1 an increased transfer, and that means that type 1 will then choose the right contract. And the mathematical programming problem ensures that this is done in a way that's optimal. So the asymmetric information problem and the informational rent is dealt with in a way that's efficient. This last problem here I'll leave you to have a look at, but if the farmers are in different proportions in the population, then you can easily adjust the solution by just weighting the objective function values by the proportions that the farmer types appear in the community. Okay, so just to summarise agri-environmental policy, we've looked at contracts. We started off, we looked at the perfect information solution and worked out that if you have two types of farmers, you want to offer them different contracts. And then we looked at the problem of moral hazard. So what you do when you can't observe actions and you have to have monitoring and you have to have a system of fines. And then we made the point that the monitoring has to be consistent with what effort you want from the farmers. And then the third one is adverse selection, and this is probably one of the biggest ones in terms of agri-environmental policy. How do you try and increase efficiency by offering farmers separate contracts, but where you've got the problem that you can't actually observe their costs directly as a regulator? So that completes topic 4, part 3.